In this video, I'll create an MCP server from scratch using only Python and its built-in libraries. We won't be installing any Python libraries like MCP or FastMCP. There are two major transports supported by MCP. The first one that we are going to focus on in this video uses standard input-output. Once you understand this one, it will be very straightforward to understand the other one that uses HTTP instead of standard IO as the transport. Let's start with the standard IO one. Here, the MCP client like Claude or Codex runs our Python program by simply using a Python command. The MCP client then sends JSON requests through standard input and reads response from the MCP server through standard output. Let's go back to VS Code. The first step is to get the standard input into our application. We import the sys module. We can get the standard input using the stdin.readLine method. I will also print the input. If I now run the application and add some input, you can see the application receives our input. Since our application will be doing a lot of back and forth communication, we will put it in an infinite loop. The MCP client and MCP server communicates using JSON. So we import Python's JSON library, strip any surrounding white spaces from the input, and parse the JSON with the JSON.loads function. MCP specifies that this JSON shouldn't be just any random JSON. Instead, it must be in a special format called JSON-RPC 2.0. In its simplest form, JSON-RPC specifies that the request JSON must have a JSON-RPC version, ID, method, and an optional params key. When the client launches this MCP server process, it first sends a request with the initialize method. We will handle it here. The response from the MCP server will also be JSON-RPC. So we have the JSON-RPC version, ID, and we have a result key instead of method and params. MCP specifies that in response to the initialize method request, we should return all the server information like name, version, capabilities, and protocol version. Then we go ahead and serialize the response back to JSON and write it to standard output. Make sure you flush because standard output is buffered. Without flushing, the client may wait before seeing your response. I can also remove the print statement. It's no longer needed. We can run and test it. If we send an initialize method request, you can see I receive my hard-coded response. The next step is the handshake. The client sends a notification with the notifications initialized method. We don't return anything because this is just a notification from the client saying it's initialized. Let's now make our MCP app a little more interesting by adding tools. MCP defines another method tools list in which the server returns the list of all tools available on the server. The response will again have the JSON-RPC version, ID, and result key. Inside the result, we have a tools key containing a list. The tool is defined as a JSON object and the tool must have a name. Optionally, you could also add a description if it's not obvious from the name. Because anything you add to the tool specification consumes tokens, so use it judiciously. And we have an input schema where we define the arguments accepted by the tool. For this particular tool, we are expecting name as an argument. Let's test it. To get the tools list, the MCP client will send this payload. It successfully returns the tools list. Of course, we haven't implemented the tool yet. Let's do it now. For tool call, MCP introduces the tools call method. We get the params. The sample tool call params value looks like this. It has a value tool and the argument. If we get the hello tool call, and remember we defined in the input schema that we need a name input in this tool call. This is a simple hello tool. It simply adds hello before the name and an exclamation mark at the end. The response is pretty much similar. It has the JSON-RPC key, ID, and result key. The interesting part is inside the result key. The result has a content key which contains the output of the tool call. It's a list of JSON objects, each with a type and text. If we now start the MCP server and run the tools call with params containing the tool name and arguments, in the response, we get the output under the result key. Before we go to the HTTP implementation, I would like to add one more thing, handling shutdown. It's simple. If the standard input is empty, we break out of the infinite loop. Now our MCP server is ready to be connected to any client. At this point, the client may send any supported MCP request, such as listing tools or calling one. Let me add it to Codex in the CLI. You can also do it with the VS Code extension or the desktop application. To integrate the MCP server, we use the Codex MCP add command for load by name we want to give to this MCP server. For a standard IO based server, we use double hyphens. Finally, the Python command to run the script. Press enter. It says the MCP server is added. You can also check it using the Codex MCP list command. If I run Codex, I'll ask it to greet Ronaldo with the hello tool. It asks for permission to run the tool. As you can see, it called our tool for greeting. I hope you now have a very clear idea of what's happening under the hood in an MCP server. Of course, this was a very simple MCP server. You can do a lot more than this since you are able to execute Python. You can do anything like file operations or database operations, exposing calculation models, running smaller ML models. Basically, the possibilities are endless from here. Before I end this video, I want to quickly show you MCP over HTTP. This is a fast API application, and the request and response payloads are communicated over HTTP instead of standard IO. Here I have created a post endpoint. Then I get the request JSON, which replaces getting JSON from standard input. Another important change is that for notification method, we should return a response with a 202 status code. And finally, instead of writing to standard input, we simply return the JSON response. That is it. This is MCP over HTTP. The protocol remains exactly the same, only the transport changes. Instead of standard IO, it's now HTTP. I hope you now have a very clear understanding of what MCP server actually are. I have just scratched the surface in this demonstration. The specification is huge. They have covered authorization, streaming, error handling with codes, and many other features. It is better to use out-of-the-box solutions like FastMCP instead of reinventing the wheel. These libraries keep the protocol handling up to date, so you only need to focus on your features rather than the protocol.